Hello, my name is Emily, and this is my independent project presentation about the analysis of hummingbird feeding patterns in relation to attraction to UV light. So, a little bit of background about my project is I picked this project based on a really cool feature of hummingbirds that is unique to them in relation to humans is that they can see well into the UV spectrum of light with their eyes, whereas humans definitely cannot. We have a pretty narrow range of visible wavelengths that we can see, and hummingbirds can see beyond that. Essentially the way that they are able to do this is they have specialized super tiny little oil droplets in their eyes that essentially act as filters that allow them to distinguish more colors than we as humans can. They can also distinguish whether a plant or anything else in nature or in their little worlds around them absorbs or reflects UV light, which is pretty cool. And I actually got this idea for this experiment from learning about bees in a different class and the ways that bees can also see into the UV spectrum of light and how that can be related to their attraction to certain flowers that absorb UV light. They have special pigments in the center of flowers that absorb the UV light and allow the flowers, the center of them, to kind of act as like a little landing pad for the bees, and bees tend to prefer these flowers over others. So that's where I got the idea for this experiment. And a lot of the previous literature and experiments that have been focused in this realm of hummingbirds and eyesight and attraction to their feeding sources has been focused on human wavelengths, human visible wavelengths of light. So, like blue versus red versus green. And it has been established that hummingbirds are generally more attracted to blue and red wavelengths of light that are reflected by flowers. So, generally more attracted to red and blue flowers. But there hasn't been a lot of research into whether their really cool ability to see into the UV spectrum of light has any effect on their flower choice as it can for bees. So the hypotheses for this experiment, the null hypothesis is listed here, but it's kind of wordy, so I'll just kind of explain it. Essentially, the null hypothesis being tested was that there would be no significant difference between the mean number of hummingbirds that visited a feeder that had UV lights attached versus a feeder that had no UV lights attached. And the alternate hypothesis is the opposite, that there would be a significant difference between these two um, means for the two feeders. And the prediction was that there would be at least a 25% increase from the mean number of hummingbird visits to the feeder from there would be a 25% increase from the feeder without the lights to the feeder with the lights in terms of hummingbird visit means. And essentially how I carried out this experiment was I chose a location, in this case, a family friend's backyard, who had an established hummingbird population as well as a feeding location that the hummingbirds were frequently used to getting food from and used to visiting every day. And so this location is seen in the left-hand picture here. It's actually a screenshot from the recordings that I took as data for this project. So there were two feeders, two red feeders. They were as close to identical as I could get them within the time frame of this quarter, and it was already an established feeding location that hummingbirds would go to every day to get food and expect to get food. And UV lights, little pocket-sized, about this big, UV emitting little pocket flashlights were attached using Scotch mounting squares to the feeder on the right hand side in that picture with both. And the feeder in the photo that's on the right is actually the feeder that's on the left in the picture. I know that's a little confusing, but just to kind of give you a close up view of what the feeders look like. And the flowers at the bottom are where the hummingbirds actually stick their beaks in and drink the nectar from. So choosing this location was actually super important because it can take weeks to months for hummingbirds to get used to a new feeding location. So for future experimentation, this is really important and key. And the data was actually taken using a GoPro. I took about 2.5 to 3 hours of footage every afternoon of the two feeders, and then I went back later and watched it and took data on the number of hummingbirds that went to each feeder. And then this data was then analyzed using RStudio after putting the data into a table in Excel. And this data was taken over a period of 5 days. And it was analyzed using a one-way ANOVA test. So as far as results, you can kind of see in the ANOVA output up in the top right-hand corner. The most important part of that is the p-value, which is indicated with the teal arrow. And the p-value is 0.629, which is significantly greater than the alpha value being used, which was 0.05. So essentially what this means is that we failed to reject our null hypothesis. So we cannot conclude that there is a significant difference between the mean number of hummingbirds that visited the 2 feeders over this 5-day period. And for kind of a more visual representation of the data, we have that side-by-side box plot figure right there. And the box plot on the right is representing the feeder with the UV lights, and the one on the left is the feeder without the UV lights attached. And another really important part of the results for this project were the conditions for the ANOVA test to actually be carried out in the first place. So there's 2 really important conditions. And the first one is homogeneous variance. And that condition was met, as you can see in the residual plot on the left-hand side. That condition was good and that condition was met. But the second condition for the results of ANOVA to be a valid test to be used on the data is the normality of the distribution of the data itself. So as you can see in the plot on the bottom right hand side, it's a histogram that shows that the data has a pretty severe right skew. So it's not normally distributed. So that means that we can essentially draw no concrete conclusions from our ANOVA analysis, which is kind of a bummer. And then as far as the discussion of the results, again, we can't really draw any concrete conclusions for this experiment. So essentially it's just providing a baseline of what to do and what not to do for future experimentation. So there were unfortunately several variables that could be proven to possibly be confounding variables in this experiment. The feeders, obviously from that picture, were not completely identical. They were pretty darn close, but again, not 100% identical. So that could have caused a preference issue. And the way that I had planned on controlling for this was I was going to switch the lights from the one feeder to the other halfway through the week, and then still continue to take data based on just like UV lights versus no UV lights. But I was actually not able to do this because due to the COVID-19 pandemic, a lot of shipping companies and such are just not able to meet their deadlines. So I ordered these UV lights well before I was going to start the experiment. I had actually planned on taking 2 weeks worth of data, and they were originally supposed to have like a shipment date of like 3 days after I ordered them, but I didn't get them for almost 3 weeks. So that really messed with my timetable for my experiment. So I really just had to make the best of what I had. So wasn't able to provide the adequate controls that I wanted to, but in future experimentation, that would be really important to provide for. And then these are a couple people that I just want to acknowledge really briefly. Full acknowledgements and the reasons why these people were super important for me completing this project and having it be as awesome as it was are in my full report. But yeah, here listed are just a couple of people that made this possible. So thank you to all of them. And then I have my literature cited page, and only one of these is actually cited in this presentation, but the other 2 just provided general background that is more specifically mentioned in my full report. So that's all I have for you. Thank you so much for watching my presentation and reading my report. I appreciate it. Bye.